Hello class, this is lesson 58. We're studying something here called the distance problem. This concept involves familiar ideas, but it can be a little tricky the way the problems are worded. So I want you to stick with me here. This video is going to be probably a few minutes longer than some of the others. So distance problems involve ratios. So we've been studying ratios or rates. We know that for any one particular ratio, there's a second one, which is the reciprocal. So distance problems involve rates of speed. So in our first ratio, we see that Joe or whoever can drive 60 miles in 1 hour. That implies a second ratio, which is the inverse of that. We flip that and we say that in 1 hour Joe can drive 60 miles. So any rate has two possible representations. The one and then the inverse of the one. So let's look over here on the right, right here. When we did unit conversions. This is comparable to saying in 1 foot there are 12 inches, and then I would always tell you, flip that for your second possible unit conversion, and there are 12 inches in every foot. Okay, so 1 foot over 12 inches over 1 foot. So every unit conversion has two possible ratios that you can use. Distance problems are more similar to something we did a little later where we talked about other kinds of rates, where we talked about not units, but we talked about, for example, we could say here, Justin could shovel 5 sidewalks in 20 minutes. We can also state that a different way, same information. In 20 minutes, Justin can shovel 5 sidewalks. Same idea. You have one rate or ratio, you flip it, and you have a second one. And then depending on what you're looking for, you might use ratio 1 or you might use ratio 2. And I told you that if, for example, you wanted to find out the number of sidewalks, you would use ratio number 1 because it has sidewalks on the top. If you wanted to find out a length of time in minutes, you would use ratio number 2 with minutes on top. You always wanted to use a ratio on, that had the number on top, the unit on top that you want to end with. Okay, coming back to our distance problem. So the ratio right here, 60 miles per hour, it's very familiar to all of us. Every one of us knows this particular type of ratio. We typically would say something like 60 mph, right? 60 miles per hour. That's just another way of stating 60 miles over 1 hour. It's just stating that ratio in a different way, miles per hour. Same thing. So this is something we're all familiar with, and this particular ratio has a name. It's called speed. Whenever we see this ratio with time on the bottom, that ratio is called speed. There you have it. There's speed. The other ratio has time on the top, and that's used also, but we don't call that speed. That's hours per mile, whereas our first ratio, speed, is miles per hour. Right? How would we use these? Well, let's say we want to figure out how far Joe could drive in 2 hours. Okay, so how far could he drive in 2 hours? We're looking for a distance there. We're looking for miles. How far is Joe driving? So we're looking for miles in our answer. Go back to black here, right? Our answer is going to be in miles. That means we want to use 60 miles over 1 hour. Okay, I didn't leave enough room for my answer there, and then just like we would do with unit conversions or other types of rates, we use the information given, which was 2 hours. We multiply it by the proper ratio. In this case, it's 60 miles over 1 hour, and we get our answer. So that would be, oh my goodness, I'm having pen problems. 2 hours times 60 miles. All right, our numerator is simply 1 hour. And this cancels. And I'm left with 2 times 60 on top, or 120 over 1 hour, and that's just 120 miles. I hope you guys are keeping track of my mistakes. Okay. Yes. All right, so that's very similar to unit conversions, but we're working with rates of speed and distance. So if we look at this, as our answer here was a distance, call it D, and we call this a rate. It's a rate of speed, and then we call this just time. We have an equation then. I'm going to bring our D over, start with it. We can say that D equals time times rate. All right, let's write that up here. I need some room. We're going to want to remember that. D equals, I'm going to put the R first, rate times time. Okay, that is the type of problem I just solved. I was looking for distance in miles. I multiplied a rate times a time. Right? So let's leave that there, and let's move on to the other type of problem we can solve using these two ratios. So I just looked for a distance. What would be the other kind of problem I would solve with these two ratios? It would be an answer in time. So I would use, if I want to end in time, I would use this here one, because I have the units of time on top. So I'm going to be using this here ratio. Let's say I want to know how long will it take Joe to drive 180 miles. Let's abbreviate that M. All right, we have 180 miles. We're going to convert that into, or rather, we're going to use that to find out the information of time. How long will it take Joe to travel that far? We have our unit multiplier, our rate with time on top, right here. And our answer is going to be in time. It's going to be in hours. So now let's do the math. We cancel these units. We have 180. This is a somewhat unnecessary step, but I'm going to do it for clarity. And we have 60 on the bottom. Okay. And now if I do the math, 180 times 1 is 180, divided by 60. 180 divided by 60 is 3. It would take Joe 3 hours, okay, to travel 180 miles. So let's call this, our answer in hours is time. This is called, it's a rate. It's a different rate than the one I used in the first problem, but it is a rate. And the number that we started with there, that was in miles, so that was a distance, or D. I'll call this R. All right, just like I did with my first equation where I came up with this D equals R times T, I'm going to use my D and R and T and write this one out as an equation. I'm going to come right up here below. I'm going to write T. We see that it was equal to D times R. The book likes to put the R first. I'm going to try to do what the book does. So what they do is, depending on which rate they use, whether they use this one or whether they use this one, you can calculate either distance or time. And there are two equations that you get from working those problems. You can, from that, figure out that distance equals a rate times time, and time equals a rate times distance. Why am I telling you that? Well, let's say later you are given some word problem, and they want you to calculate distance. They want you to calculate distance. Well, you can use either one of these now. You can use whichever one you like, because here's distance right here, and here's distance right here. And if you recall from our 2 out of 3 problems or our missing number problems, you can solve for the answer or you can solve for one of the factors, remember? And that's like factor 2, I'll call it. Okay, so you could take either one of these equations here on the right, and you could insert the values that you have, rate and time, and you could use either one of them to solve for distance. That's important because in your practice, they're going to say something like, solve 2 ways. What do they mean by solve 2 ways? What they mean is they want you to use this equation to solve what you're looking for, and then they want you to use this equation. And honestly, I can't remember if it's distance or time, but if it were time, if you were looking for time, it would work the same way. You can use this equation to solve for time, or you can use this equation to solve for time. And the only difference between the two is the rate that's used. When you are solving for D as the answer, the rate is always, it always has time on the bottom. So it'd be 60 miles per 1 hour. Okay, this is the rate you're going to use when you solve for D. So then obviously if you're solving for time, you're going to use the other rate. There's only 2 rates. So if you've used up the one, obviously you're going to use the other one. So in your practice, when it says solve 2 ways, remember there's 2 possible rates. And now that you have these 2 equations, distance equals rate times time and time equals rate times distance, you can use either one of those to solve for distance or either one of those to solve for time. The only difference you have to remember is that you have to know which rate to use in each equation. Okay? When you solve for distance, just remember this, you always use the speed one. You always use the speed ratio. Speed is the ratio with time on the bottom. Speed has time on the bottom. Remember that. Just say that to yourself a couple times. The ratio for speed has time on the bottom. All right? Now let's work a couple of these. It kind of takes a lot of setup to get where they need to get to solve problems, and that's why this is a little bit confusing. But if you remember your concepts for rates and ratios, it shouldn't be too bad. Let's see. Okay, so let's say that Sophia jogged 60 miles in 15 hours. Let's see. How much is a marathon? What is that? 26 miles? It's probably marathon speed, I'm thinking. She's jogged 60 miles in 15 hours. So from that, we get 2 different rates. 60 miles in 15 hours. And once you get the one, the other's very easy. Just flip it. There's your 2 rates or ratios. Which one is speed? Which one do we call speed here? What do they say? Speed is the ratio with time on the bottom. However, when we talk about speed, we usually like to say miles per 1 hour. So we're going to go ahead and divide 60 by 15. That's 4. And we'll keep it as a fraction or a ratio so that we can say 4 miles per 1 hour. And same way, our second ratio is going to be 1 hour per 4 miles. And I got that just by dividing 60 by 15. That's 4. And I left it as a fraction 4 over 1. All right. So now we have 2 ratios. And so they can ask me 2 questions. They can say, how far can Sophia jog in 45 hours? And we want to know how far. The second question they could ask is, how long does it take Sophia to jog 120 miles? So how long? 120 miles. Okay, so let's answer those 2 problems. Where can I write it here? What should I erase? Okay, have our two rates. I'm going to erase this other stuff because now we have our two rates that we're going to be using, 4 miles every 1 hour and 1 hour for 4 miles. Okay, so how far? So we start with the information given. We start with that 45 hours. And we multiply it by the proper ratio. If I want to end, how far is asking, they want an answer in miles. And so obviously we have to pick the one with miles on top. So that's going to be 4 miles for 1 hour. And so we're going to go 45 times 4. And that's, we're going to cancel hours. We can keep our 1 as denominator. And I'm going to have just miles left. 45 times 4 is 180. She can jog 180 miles in 4 hours. Did I say that right? In 45 hours. I'm sorry. She can jog 180 miles in 45 hours. Okay, so that's how we would work our first type of problem, asking how far. Okay, so they can ask how far and they can ask how long. How long? You have to be able to answer either one. So how long? What's the information they give us? How long will it take her to jog 120 miles? We only have our other ratio left. Since we want to end in hours, we have to use the ratio with hours on top. Once again, we've done this so many times now with unit multipliers and other rates. Cancel those units. You can see you have the right units left, just hours. And then we just do our math. 120 times 1 over 4. What is that? 120 times 1 is 120, divided by 4 is 30. 30 hours. And that's our answer. So this is going to be very similar to unit multipliers in that you're going to have two possible ratios, and then you have to figure out when they ask you a problem, which one do I need to use? Okay, it's always going to be the one that has units on top that you want to end with. All right, what else are they going to ask you in this? Okay, I told you they're going to, in the practice, they're going to tell you something, they're going to ask you a question, then they're going to tell you to solve it two ways. And that's where those two equations come in. Distance equals rate times time, and time equals rate times distance. And I told you that the only difference between these two equations is the rate that they use. In this one, you have to use the rate of speed, and that's miles per hour. So I'm going to write a little, just to keep you reminded, I'm going to write MPH, miles per hour, distance. And then the other rate is obviously the flip of that, which would be hours per mile. Obviously, the more familiar one is miles per hour. That's the one we talk about, think about every day, especially when you start driving, miles per hour. So distance always uses the rate miles per hour. Time is on the bottom. So let's see. Let's say that Ben drove 80 miles in 4 hours. I'm going to use black, sorry. Let's say Ben drove 80 miles in 4 hours. So from this we can infer two rates. One is 80 miles in 4 hours. I told you that they like to see it per 1 hour. So go ahead and do the division 80 divided by 4. That gives you 20. Write that as a fraction. So even though 80 divided by 4 is just 20, it's a whole number 20. Let's write it as the fraction 20 over 1 so that we can say 20 miles per 1 hour. All right, and that's my speed. That's the ratio that's called speed because time is on the bottom here. Now the other one is just the flip of that. In 4 hours, Ben goes 80 miles. Again, we divide. It's going to be obviously the inverse, so it's going to be 1/20th. 1 mile. I wrote that wrong. I'm so sorry. We want to have it always be 1 hour time chunks. Okay. Go away, funny box. Okay, so there's my two ratios. And so they might want to know, first of all, they'll ask what was Ben's speed. I already solved that for you. It was right here. And you can write it as that ratio like that. You can also write 20 mph, right? So that's the answer to the first part of the problem. Then they're going to say something like, how long would it take Ben to drive, let's see, 320 miles? How long would it take him to drive 320 miles and solve it two ways? Let's do that. How long would it take him to drive 320 miles and solve two ways? So they want to know how long, that's an answer in miles, to drive 320 miles. I'm sorry, how long is, they're asking for time. When they want to know miles, they'll say how far. Sorry, I thought I'd beat the clock on the next music. It comes every hour on the hour. It's now noon. Okay, let's just listen for a moment for your listening pleasure. I'll write out the first equation. Okay, so in this problem, they're asking how long. That's an answer in time. So we're looking for t. So if you look over here at my equations on the right-hand side, remember there's two different equations. One is distance equals rate times time, and one is time. The other is time equals rate times distance. I'm going to use each one of those to solve this problem. So we already had the two rates. It was 1 hour. 20 miles. Clock throws me off. In 1 hour, he could go 20 miles and 20 miles per 1 hour. It's important. I'm going to need these two rates. All right, so let's go ahead and use this one first. So we're solving for time. Our distance is 320 miles. That's our D. Okay, equals, we need a rate. Which rate do I use? I told you that when you're solving for D, when you have the D equals R times T equation, you need to use the speed ratio, and that always has time on the bottom, so that's this one here, right? That's this one, that's speed. So let's say 20 miles per 1 hour, and then I'm actually looking for time. That's the variable that I'm looking for is t. All right. So to solve this, I am going to multiply by the inverse of 20 over 1 on both sides. So I'm going to multiply by 1 over 20. I have to do it to both sides. What's going to happen on the right? As you know, we cancel all that gobbledygook. Everything gets canceled. I'm left with just t, which is good. I want t by itself. On the left-hand side, I'm going to cancel the units miles. And I'm going to end up with these numbers. 1 times 320 over 20. The only units I have left are hours, and that equals 320 divided by 20 is 5, 10, 15, 16. 16 hours. And that's my final answer. So I found the answer 16 hours by using the D equals R times T equation. So I'm going to come up with the same answer, but they want to see you use the T equals R times D. So let's go ahead and do that. You're going to think, why do I have to solve this another way when I already know it? I don't know, just so you're versatile. Okay, so the other equation we want to use now is this one. T equals R times D. This is actually kind of nice because it already has T all by itself. This is actually the easier one. So it equals, what rate do we want to use? Well, we already used this one. So now I want to use this other one here. 1 hour over 20 miles, 1 hour per 20 miles, and multiplied by our distance, which was 320. And we see that we cancel miles, and we're going to end up with exactly the same numbers to multiply, divide. Once you get the first, once you solve the first way, the second one's very easy. You already have all the math done. All right, so that ends up being t equals, again, 320 divided by 20, which is 16, and my units were in hours because I canceled all the miles. There you go. I just solved this problem 2 different ways. Remember, when it says solve 2 ways, what do you want? You want to do it once this way, and then you want to do it this way. Once you get one of them down, the other one's easy. The only difference between the 2 is obviously the order, D, R, and T, and T, R, and D, but the other difference is the rate that you're going to choose to put in for R. And when it's D equals R times T, or distance equals rate times time, you always use this here. I can't circle it enough. That's called speed. It's 20 miles per hour in this example anyway, and that's when you use when you're solving for D. Once you can remember that, then you know solving for T uses the only other rate. All right, that was a little bit complicated. Hope you guys catch on to that. I'll be reviewing that for sure. Signing off.